Hi there. My name's Josh Timonen, an iOS developer. Many iOS applications need to notify users of an event, whether the app is open or closed or in the background. For example, it could be an alarm, a new message from a friend, or a 15% off sale. To achieve this, iOS uses local and push notifications. In this workshop, we're going to focus on local notifications, which aren't talked about quite as much as push notifications. Here's the difference between the two. Push notifications are created and sent remotely from a server. Local notifications are created and registered by our app, and then triggered by the operating system at a specified date and time in the future. They work in very similar ways, with very similar structures and methods. So learning how to use local notifications will equip us with most of the knowledge needed to handle push notifications as well, without needing a remote server. Local notifications could be used in a custom alarms app featuring your own custom sounds, or perhaps a workout app that notifies the user when to start working out and then when to change exercises. Local notifications are great for any apps that need to notify users at known intervals or specific times of day. We'll learn to use local notifications to trigger app behaviors, add a badge number to our app icon, play a sound during a notification, send our app data, and handle the notification one way when the user is in the app, and then a different way when they're outside of it. Okay, so let's get started. First, let's open Xcode and create a single view project. We'll call it Local Notification Demo. Open the app delegate implementation, or .m file. Starting in iOS 8, we need to request permission from the user to display notifications. We need to create a UI user notification settings object with the types of notifications we want to use. For this demo, we're going to use all three: badge, alert, and sound. We'll do this in didFinishLaunching with options. We create this object with the class method UI user notification settings, settings for types, and then entering in the types separated by the pipe. We'll also leave categories nil. We then call Register Notification Settings on the application with this notification settings object. This will present an alert to the user requesting to use notifications. For this workshop, we're going to assume the user will always click yes. There are callback methods we could be listening for that would tell us the user's choice, and we could branch our app's behavior accordingly. We'll also be only building for iOS 8. If we needed to support iOS 7 or earlier versions, we need to do some additional code branching. Now, let's launch the app in the simulator by hitting the play button or using the hotkey Command R. We'll see the system alert asking for permission. Hit OK. Back in Xcode, in our appdelegate.m file, we'll create a new method right below the didFinishLaunching with options method, named GenerateLocalNotification. We'll then call this method inside didFinishLaunching with options right before return yes. This will call our method and the code we're about to write as soon as the app is launched. In our GenerateLocalNotification method, we'll create a UI local notification instance named LocalNotification. Now that we've created it, we'll want to set some of its properties. First, we'll set its fire date property, which is an NSDate object. This will be the time that the notification is triggered. Let's trigger this notification 15 seconds after launching. So we'll create an NSDate with init with time interval since now, 15. This creates an NSDate 15 seconds into the future from when this code is run. Next, we'll set the alert body property to an NSString. This will be the text displayed on the notification when the user is outside the app. Let's set it to my first local notification. Next, we schedule the notification with the application. We do this by calling UI application, shared application, schedule local notification, local notification. We've now created and registered a local notification that will trigger 15 seconds after our app launches. Now, let's launch the app in the simulator. Once the simulator is open, go to the top menu bar and select Hardware Home. This simulates hitting the Home button on the phone. There's also a hotkey for this, Command-Shift-H. Within a few seconds, we'll see the notification appear at the top of the screen with our custom message. And tapping this notification takes us to our app. So now we've generated our first local notification. Next, let's badge our app icon when this notification is fired. On our local notification object, we set the property application badge number to our desired integer, let's say 3. Now, if we build and run our application, we'll again simulate tapping the Home button to background the app. We wait a few seconds and our notification fires. We can also see that the app icon is now badged with the number 3. We can set the sound name property on our notification to the standard notification sound with UI local notification default sound name. If we want to use a custom sound file, we need to first add the sound file to our project. We'll add this sax.aif file. Make sure we add the file to our local notification demo target, then click OK. Now we can set the sound name to sax.aif, and this will play the sound with the notification when it's presented from outside the app. If we launch the app, simulate the Home button and background it, then wait for the notification to fire, we'll hear our custom sound when the notification is fired. Let's also add some basic data to our notification in a dictionary structure. We're going to keep it simple here, just a single key and value. We assign it to the user info dictionary on the notification. We're just going to set an ID to the number 42. When we receive the notification, we'll read in this data and do something with it. Next, let's take a look at how local notifications are handled differently when triggered from outside the app or inside it. To trigger a notification from outside the app, the user needs to tap the notification bar across the top of the screen or swipe across the notification on the lock screen. When this happens, a method is called in the app delegate called application did receive local notification. If the user is inside the app when the notification is triggered, this method is triggered automatically with no action needed from the user. So let's set up this method in the app delegate. We want to set up some branching here to behave differently if the user was inside or outside the app. We want to check the application state property. If UI application state active, then that means the user has had the app open when the notification was triggered. Let's create a method called takeActionWithLocalNotification that accepts a UI local notification object. Inside this method, we can then access the notification's user data dictionary and get that ID we set. We'll assign it to an NS number called Notification ID. Then, let's just present an alert telling the user we are viewing the notification with this ID. We'll use the new iOS 8 UI Alert Controller class to do that. So again, if you need to support iOS 7 or earlier, you'll need to branch for that. We'll create an alert controller object with the title Action Taken and the message that we are viewing notification and then the notification ID number. We'll set the preferred style to UI Alert Controller Style Alert. So this code just presents an alert with a string in the message field that will display our ID. Of course, in your app, you'll probably want it to do something more, but this at least lets us see that an action has been taken in the simulator. We then present this alert controller just like we'd present a view controller with self.window.rootViewController, present view controller, alert controller, animated yes. So if the application receives the local notification from outside the app, we just want to call this method takeActionWithLocalNotification, passing in the notification. So if a user was outside of the app, then taps on this notification, the didReceiveLocalNotification method will be triggered, and we just want this action to be taken immediately. There's no risk of interrupting the user here, so we just call our takeActionWithLocalNotification method. If the user was inside our app when the notification was triggered, we need to first tell them that the notification has happened and allow them to choose to take the action or ignore it. First, we'll create a basic alert controller with the title Notification and the message set to the notification's alert body. Next, we'll need to create two UI Alert Action objects, one to ignore and one to view. First, we'll create the ignore action with the UI Alert Action class method, action with title, ignore, style, UI Alert Action style cancel, then handler, which is our completion block. Nothing's really going to happen in this completion block, so we'll just do an NS log with the text ignore. Similarly, we're going to create a view action object with the title view and inside its handler block, we'll call the Take Action with Local Notification method. We're also setting its style to UI Alert Action Style default. Next, we add these actions to our Alert Controller object with the method addAction, passing in our UI Alert actions. Then we present our Alert Controller from self.window.root view controller, just as we would a modal view controller again, with Present View Controller, Alert Controller, Animated Yes, and then an empty completion block. Now, let's test the notification both ways. First, we'll test triggering it from outside the app. So, we'll launch the app in the simulator, then background the app, and wait for the notification to trigger. When we see it appear at the top of the screen, tap it, and we'll see our application launch, then show us the alert stating, "We are viewing notification 42. We have successfully taken this action." You'll notice, though, that our alert doesn't have an OK button. So let's go back to our Take Action with Local Notification method in the app delegate, and we'll add an OK action to that alert controller before presenting it. If we relaunch the simulator, then background the app again, and tap on our notification once it fires, we'll now see that we have an OK button. Okay, so now let's relaunch the app in the simulator, and this time let's stay in the app until the notification triggers. This time, we see the app presents us with our alert controller asking if we want to view or ignore the notification. If we tap View, we see our Action Taken notification as expected, stating we are viewing notification 42. If we relaunch the app again and wait for the notification to trigger in the app, then hit Ignore, we can see that nothing further happens as desired. So now we've learned how to register and handle local notifications. There's a lot more we can do with these, and hopefully this workshop serves as a good launching point for your own experiments and investigations. Thanks for watching.